Hi everyone. I want to do a sample problem having to do with the volumetric expansion equation. And I thought if we're going to do one, let's do one that's kind of fun. I have had many students through the years who have come to me with information like this. You can find this on the internet. Here's the website where I found this. And this is basically what it says. The idea is if you want to save money at the gas station, get up early in the morning, and buy gas when it is much colder. And the idea is that if you buy gas when it is colder, you are going to be getting more gas for your dollar because of volumetric expansion. Here is another website that is giving the same piece of advice. Buy gas early in the morning before the earth starts heating up, right before dawn. So we're talking usually about 4 or 5 in the morning, depending upon where you are and the time of year. And that by doing this, you are actually, due to changes in density and volume, you are going to get more gas if you buy it when it's cold. Well, I like numbers and I like looking at numbers, so let's actually do the math. Let's see how much money you would actually save by buying gasoline very early in the morning when it's cold versus right in the middle of the heat of the day. And let's see what we're talking about. So here's my equation. The change in volume is going to be original volume, beta, coefficient of volumetric expansion, times change in temperature. So I chose to do the math with just 1 gallon of gasoline. Coefficient of volumetric expansion for gasoline is 950 times 10 to the negative 6th per degree Celsius. Yes, this is a much bigger number for volumetric expansion because we're talking about expanding in 3 dimensions, and when linear expansion, this was typically only 1 digit. Now, what about change in temperature? Well, I wanted to pick something that was realistic. So I said, well, in a typical day from highest to coldest, you get about a 30-degree Fahrenheit swing. So maybe it's 40 degrees at dawn and maybe it's 70 degrees during the day. Or maybe in the winter, maybe it's 10 degrees at dawn and maybe it gets up to 40 during the day. Or on a hot summer day, maybe it gets down to 60 at night and up to 90 during the day. So I figured a 30-degree Fahrenheit swing was probably a pretty good change in temp, and that equals 17, right about anyhow, 17 degrees Celsius. So when you do the math on that, the change in volume ends up being 0.01615 gallons. Now, I don't know about you, but I do not buy just 1 gallon of gas when I go to the gas station. So let's make this a little bit more realistic, and let's say I bought 10 gallons. So if I multiply it by 10, because I got 10 gallons at my fill-up, that's going to be 0.1615 gallons of gasoline that I got more. Okay, well, the idea is saving money. So how much money is that? Well, if gasoline is selling at $2.50 a gallon, and I know that it goes up and down depending upon, who knows, sunspots, who knows what causes that, but if it's $2.50 a gallon, we're talking about a savings of right around 40 cents. So for that 40 cent savings, is it worth buying gas at 5 a.m. instead of buying it in the heat of the day at 3 in the afternoon when you happen to be out and about anyhow? And as we're going through this, if you keep having this feeling in your gut like, there's something wrong here, yeah, let's talk about that. Where do they store gasoline? Gasoline is stored in, most of the time, tanks that are underground. And the approximate underground average temperatures are about equal to the annual average temperatures for that part of the country. So if you happen to live in the North Country, the average annual temperature for the northern part of North America is about 55 degrees. The middle of the continent's about 65, and if you're down south, maybe about 75. So the gasoline is not changing temperature as rapidly as the air does because it is insulated by all this dirt and the ground. And the few moments that it is going through the ground pipe into your automobile, it really doesn't have a lot of time in order to expand. So this kind of shoots in the foot the whole concept of getting up at dawn to buy your gasoline. But not everybody stores their gasoline below ground. At our local airport, they have above ground tanks, and above ground tanks are becoming more popular because of the fact of environmental hazards. Below ground tanks, if there's a leak or something like that, you don't know what's going on, and it can leach into the ground dirt. So if you happen to be buying from an above ground tank, again, you are counting on the fact that this volume of gasoline is going to be changing its temperature as quickly as the air. Probably not, but you might save yourself a quarter or a dollar maybe when you're filling up your Cessna 150. I don't know if that's going to work. All right, we'll see you next time. Bye-bye.